I woke up really early this morning to go to France to get some tomato leaves.
This is from like 3 hours ago.
This is
Fresh.
from 2 or 3 hours ago.
Yeah.
And let's put a small paper underneath before I damage the nice desk that we have here. So hopefully we still have some time.
Yeah.
So I'm always using, because if you go online you hear a lot of stories like just use a garlic press and you squeeze the sap out of it. I tried that. If you're lucky it works. Maybe because we were talking about the pepper crop, I was surprised because yesterday I did a brix reading on pepper crops. The sap comes out really easy.
Okay.
It's like, you will see it, it was just pouring out almost. I've done it a lot in strawberries, really difficult.
Okay.
So you're with a garlic press in strawberries,
It's not going to.
You're doomed, I think,
yeah,
but
okay.
hopefully it's gonna work.
Mm-hmm.
So we have the press. Here I can press it, but you will see it. But we first need to fill the bucket a little bit. And ideally, you only use the leaves. So don't put stems in it because stems they're for transport, not for photosynthesis, for example.
Are these leaves from all different heights of the
I
plant?
took them more or less from the middle of the plant.
Middle of the plant, okay.
Yeah.
So fully grown.
Fully grown. Probably if you start measuring, you will see a difference between young leaves and old leaves. Maybe that's also a nice thing that I think we have enough, Ivry. Yeah. Because you can actually, because getting the sap out is the most complicated thing.
And Mark, also question.
I
How
keep
many
going
hours?
in the meantime.
Yeah, please do. It's like a cooking webinar. So you are creating and then.
It's kind of new content.
Yeah,
Huh?
exactly.
Maybe I should also turn it around, because now here I'm pushing this thing in by, what's it
This
called?
lever.
Yeah. And then here there's a small bucket, so hopefully at a certain moment I will squeeze some sap out of it.
Yeah.
Okay.
But maybe you can tell a nice story or a joke. And then, I don't know.
So you boil to 100 degrees and then for 8 minutes. No. But regarding the leaves now, Mark, of course the faster the better. But until like how many hours can I when am I going to get different results? After how many hours am I going to get different results?
It's working pretty well.
It is?
Now I think you're quite good for, I guess, the first 24 hours.
24 hours.
I think the fresher the better.
Yeah, of course.
I don't really have experience with putting leaves aside and then wait for 3 days and then do the brix, because I directly do it when I pick the leaves, I measure it and off you go.
Maybe we can do for next time.
Yeah, that could be a nice thing. But what you sometimes see in plant sap analyzers, I see a lot of analyzers also coming from Mexico and the US and Canada. They're all sent to the Netherlands.
Yeah.
Sometimes you see in a plant sap analysis that the ammonium really goes up.
Yeah, but
high.
you shouldn't look at it, I think.
Yeah, because what actually happens is the leaves are so long in the process that proteins start to break down, and as an end result you get ammonium, and that's what they pick up.
Yeah.
So you see total nitrogen is still good, but don't look anymore at the nitrate ammonium levels, because you're a little bit screwed there.
Yeah.
Two devices.
So I was asking also, I think that's the easiest, right?
This is the easy one, this is the digital one.
And looking on it, and also not expensive, like maybe with 100 euros you can get a really nice one.
I think this also measures acidity, but if you only have the brix sensor, I think with 100 euros you're quite okay.
Yeah.
This one is even cheaper. I looked it up yesterday. What is it nowadays? Alibaba or Temu? I think it was 13 euros.
13, 1-3.
1-3.
Okay, okay. So everyone should have one of these in the greenhouse.
I think if you're, this is a little bit more expensive. So the problem is here, not in the measuring.
But still, for this one, maybe you don't need this machine yet.
Yeah.
It's going to return the investment in no time, but still you can squeeze some leaves and get some results.
I think.
And of course, something that we need to mention is we're talking about brix of the leaves again.
Yeah. Because
whenever we talk about brix,
we often talk about
not often,
fruits.
every time we talk about fruits.
Yeah, but now we talk about leaves.
Exactly.
And I think in the introduction we already discussed the table from 0 to 20.
Yeah.
0 is really bad, Now I mentioned, we talked about it. The peppers, they had a brix of 3.
3.
Yep.
I hope the tomatoes, but that's the scary thing now. What's going
We
to be
don't
out?
know, eh?
We don't know it, huh?
We can have a montage.
So here
and
we
take
have
it.
the sap,
Yeah.
and now we can put it. Shall we first do
Yeah, let's do the
the
electronic.
easy one?
Yeah.
Mm-hmm.
So you need to.
I just put a droplet here. I press the button, and then hopefully it works.
And what do you expect before seeing it?
I was already happy when I saw it. So here the brix is 7.4.
Yeah.
That was in the morning. So I took the leaves in the morning. So normally, and of course the lights were already on for a couple of hours. So photosynthesis was going.
Exactly.
But probably it will go to 8, 9,
Touching 10.
if you're lucky, 10.
Yeah.
So I think for a horticultural crop on a substrate, on rock wool actually, I think 7.4 is at least much better than the 3 in peppers.
And Mark, again, just to repeat one more time, can you bring the levels? Can you explain the levels again? Like what's on the negative side, optimal side, and can we have also too much?
I think with brix you cannot have too much.
Okay.
If you have 1 or 2, your plants are on the what is it called, infuse?
Yes, it's on the
You're really
emergency
on the
situation.
hospital, and they really need
Yeah.
every help they can get. They're not able to protect themselves.
Mm-hmm.
Basically, from 3 till somewhere 8, 9,
Mm-hmm.
you get into the range of where sucking insects get into trouble.
Yeah.
So basically, we say if you have 4 or 5, 6, by 6 the aphids will go away, but then you get the thrips and then you get the whiteflies. But when you reach, I would say 11, 12, then most of those insects are not able to digest the plant anymore.
Yeah.
Mm-hmm.
The secondary metabolites start to go up from 7 or 8.
Mm-hmm.
So when you can already smell it a little bit because
Yeah,
I put the
of
leaves
course.
here, you see the odor, and brix is everything that has to do with taste and what we smell.
It's also the green fingers from the past. I smell the crop and
I smell the
understand.
crop, and that means that you have a high amount of secondary metabolites because
Exactly.
that's what we smell.
And Mark,
But once it,
yeah,
to
please.
finish the question,
Yeah.
once it goes from 12 to 15, also beetles, I can imagine like Nasidiacoris, they will lose interest.
Yeah.
And if you go above 15, you have no issues anymore with pests and diseases.
Have you ever seen 15 in your life?
I've seen it in blueberries outside. Yeah.
Okay.
Yeah.
Outside.
Yeah,
In
but
the
that's the
Netherlands.
tricky thing, because also in the introduction webinar we did a couple of weeks ago, there are of course some issues that we have in our situation.
Yeah.
And I believe that one of the issues that we have is that we have no UVB light inside of greenhouses.
Yeah.
And we know from UVB light that it really stimulates the production of secondary metabolites. So it pushes brix up.
Yeah.
So there are even some experts in the field that say you never get the ultimate healthy plant in a greenhouse. I'm sorry to say it, but
It depends.
going
also.
from 3 to 10 is already a huge step.
Yeah, exactly.
And I'm also not saying that the aphids will drop dead once they land on the plant directly, but at least
It
if
will
we
be
can
much more
slow them
difficult to
down,
penetrate.
then
Yeah.
the biological control can take over and finish the job.
Clear. And Mark, because we're talking about more photosynthesis, more brix, so that means, for example, maybe on the peak of the day I will get the highest brix.
Yeah.
What would you propose? Like to do it in that on that time, or like in the morning, and then maybe because it's a simple method, eh? I don't
it
need
could
mo-
be.
I
It
don't
could
need
be.
more than
It
a
could
few
be
minutes.
really interesting to do it both. So if you're really interested into it, you could say, okay, today I'm going to measure it at 8, at 11, at 2, and at 6, just to see what is my brix doing the day. If you want to compare it from day to day, I would advise to do it always at the same time, especially a certain hours after sunrise.
Consistency is king, eh?
Yeah,
Always
that's with
we pray
everything.
for
Now I have to
consistency.
take off the glasses.
Role play as a pirate.
And now you tell me what you see. You know the figure already a little bit. It's good that it's exactly the same.
I
But
see
what?
7.4.
Yeah. But what more do you see, Avery? Because this one has one big advantage
That's
over.
that's what you told me and I didn't know, eh?
Yeah.
So
Normally what you see, and I think,
But it's
wait,
not as, so what you were explaining to me, Mark, because we had a discussion, okay, easier,
one moment,
Yeah,
Avery, because
please.
I'm going to go to the other screen.
yeah.
Because actually, this is what Avery sees now. So you see a chart with 0 to 20, and you see somewhere a blue line.
Yeah.
You saw the blue line, right?
Exactly.
But what did you actually see?
And also it's becoming a little bit blurry,
Yeah.
right?
Yeah.
So we were discussing about accuracy, like accuracy and ease of mind, because here you drop it and you are good to go. Here
Yeah.
you need to check also. It takes a little bit more time. But you told me that if it's quite blurry, like the more blurry the better.
Yeah.
Why?
Because the more blurry the line, the more calcium you have in your sap. So actually you get one measurement for free.
Yeah.
Yeah. So the amount of, I'm not sure if that's good English, blurriness
Yeah.
tells you something of the amount of calcium in the sap. So for example, if you do, and I've done that in the past, if you measure young leaves versus old leaves, you see that in the young leaves, the line is much more a straight line.
Yeah.
And the more you go down,
Down,
the older the
then
leaves, the more calcium, because more evaporation, the more
And
blurry
also,
the
yeah.
line gets.
And also calcium is immobilized, so it's
Yeah.
not going to go to the
No,
upper
and it
leaves, so-
always accumulates in the old leaves.
Exactly,
Mm.
exactly. Interesting.
It
Really
worked.
interesting.
It worked.
7.4, eh?
Yeah. Actually, I'm quite happy with that.
Beauty,
Yeah.
beauty.
So
And how
Theoretically-
how was the crop this morning then?
the crop was doing good. Frans and I were discussing. It's a little bit generative. The fruit size it's over 200 grams. So in the past we have struggled that the crop was generative enough. So now we did some extra stuff to get it generative.
Yeah,
And
because
now
it
you're
was
almost-
vegetative, eh?
Yeah, and now you're almost like, whoa, the fruits are so dominant.
Yeah,
We need to get a little bit of more vigor back in the head of the plant.
yeah, indeed.
So we actually made some changes to go even a little bit more vegetative.
yeah.
Mhm.
Which what we were expecting in the Netherlands under these kind of conditions is a vegetative crop, because there's not a lot of evaporation, there's not a lot of activity. So that's why we need to push. So now it was the other way around.
Yeah.
Nice. And of course,
Final topic.
of course,
Yeah.
your favorite slides, eh?
Yeah. Oh, I really love. I go here. Right?
Please
Yeah,
go,
yeah.
do your thing, do your thing,
Yeah.
please.
So the next thing, of course, because with brix you just get, it's like a total one number that tells you something. If you want to go deeper, of course, you need to start looking at all the different the minerals. We also said sugars are important, so photosynthesis is important, the distribution is important, but also the minerals that are available. Now here you see an example of a plant sap analyze from the same tomato crop that we just measured the brix with. That was last week, if I'm correct, this one.
Correct.
Now yeah, you see all the elements, all the parameters. There is a few interesting things happening at the moment. For examples, I was saying that you want the sugars to be as low as possible. The funny thing is, if you look at plant sap data from a tomato crop or a strawberry or a pepper, it doesn't really matter, and you look, and when the circumstances are, the sun is shining and we have 2000 joules, blah blah blah, good photosynthesis, you will see that the sugars are 0.2. Now we have 2. So it looks like that with what we are suffering with artificial light, and I think we're also going to do something about that again in the fall, we have trouble distributing the sugars to the other parts of the plant.
Activity, yeah?
Activity, probably the lack of activity.
Exactly.
Not enough water uptake in comparison to photosynthesis production.
Not a lot of temperature because
So
outside
you,
it's
yeah,
fine.
so you really see that sugars are accumulating at the moment, especially in the young leaves.
And that's different than the brix you measure in a plant.
Yeah,
sap.
this is, the brix is the total amount of compounds that are in the plant sap, the soluble compounds, so it can be amino acids, proteins, secondary metabolites, oils, fats, whatever is there, enzymes, hormones, the whole bunch together, everything. This is only non-reduced sugars, so glucose, sucrose, the simple sugars, coming directly from photosynthesis. So this is part of brix, but it's only a small part.
Yeah.
So ideally I want the sugars to be as low as possible, because I want them in in complex compound. I want the complex sugars, the proteins, the hormones, all the difficult secondary metabolites. And this is just a building block that we measure.
Mark, small question now, because this is interesting again. We talked about RTR, we went to RTA, which is more efficient, and then we're talking about sugar. So that can also tell me, like, hey, if it's 2, increase your RTR or RTA.
Yeah.
But if I am at 0, like if I'm a grower and I'm growing in 40 hectares and I don't want to go full throttle, so I need to be a little bit conservative just to keep the balance. Maybe I would like to see a 0.5 or something that I say there is still some sugar. Is that assumption correct or not really? Because maybe with 0,
I find that a difficult one.
Okay.
If I have to give you an answer now, I would say you always want it to be 0.1 or 0.2.
Okay,
not
do you have
more.
some? Yeah, exactly.
Because if it's 0.5,
it's too much.
Yeah, but it also means you're not converting it to something else.
Exactly.
And it's not gone when it's converted.
Indeed.
It's still sugars, it's still proteins, it's still secondary metabolites.
Correct.
So they're not gone.
Yeah. So you're producing but not using, so understood.
And
but
maybe if this one goes high, at a certain moment, plant has to convert it into starch, which is the storage sugar.
Yeah, exactly.
But the problem is that putting it into starch is costing energy. Bringing it back to sugars again is costing energy. So it's not efficient.
Yeah.
You have to directly convert it, distribute it, put it in the fruits, harvest it, get the money.
So 0.1, 0.2, good to go.
Yeah, good to go.
Perfect.
And so far that's working in all the crops,
Beauty.
what I've seen.
Beauty.
Sugars sometimes go up way higher. I have seen strawberry numbers with 6 or 7% because this is percent. So that means 1 gram per 100 grams, for example. Yeah. So you have 2 grams in 100 grams of plant sap.
Could you connect it, sugars, to brix, or it's?
I don't think so.
No,
No, there's no connection.
Okay.
Higher sugar doesn't mean higher brix. No, because you can have really low sugars and really high brix.
Yeah, it can be on the efficiency also. Conversion. Clear.
Now, then you have all the other parameters. I don't think we should go into detail.
We'll do that
too
in
much.
a different course later on.
There are some really interesting links that we are also learning. For example, which one of the most really nice things that I found out the last half years is the role of boron. We all know that boron is like an elevator in plant. It moves everything around. Yeah. So especially in the distribution of sugars, boron is the key element together with potassium. Yeah. So potassium is the elevator, let's say, and boron is touching the touch screen, decides where it's going.
Okay.
So if you have a lack of boron, which happens once the pH goes above 6.5, you know that the distribution of sugars is into trouble. Yeah. So now there are ways you can fix it. We'll talk about that later probably. And so there is a lot of connections once you dive into this. And then this is just one moment, but the nice thing is that you can also put it in lines. So here, for example, you see the sugar graph from this crop this year. So I think it's the same crop that you also use, the lit tomato crop. We always measure young leaves and old leaves. So the dashed line is the young leaves, the straight line is old leaves. And then in this case, we have the total crop from last year. That's the 2 blue lines. And now we see what is happening with the green lines. Yeah. So one way or another, this year, it's a different variety. We are struggling more to get the sugars out of the young leaves. What you normally see towards spring is that the sugars will go down, because then the sun starts helping with more activity and everything. Exactly. So that's just one example, but it would be really nice to get also the brix in this graph. But then
we can.
Yeah, but
of
then
course
you have to
we
measure
can.
it every week.
Yes.
Yeah. Now, yeah, you can do more things. People who are following us already longer, they know that I talk a lot about nitrates. Now, in this case, you see that the nitrate levels in the young leaves are really low. You see that in the old leaves, actually, the number is also really low, because if you look at a standard tomato, it's probably somewhere here, 6,000. Last year, we were already doing a reduction. You see the line around 4,000. Now we are even lower. We're only feeding 10 millimoles of nitrate more or less in the schedule.
And can we say also, Mark, that this is something, it is new, relative new for like growers worldwide, because we're thinking nitrates is also like growth, right? So I want to have nitrates in my...
Yeah, what I always say, you need enough nitrogen, not nitrates, nitrogen, so it doesn't matter if it's ammonium or nitrate in the fertilizer schedule. But you don't want nitrate in the plant sap, because nitrate in the plant sap is nothing else than unused nitrogen.
Yeah.
The plant is not using it, it stores it in the old leaves, and that's where it's piling up. Now, what you want is to have as less as possible in stock, because it's creating a lot of issues. Often you hear high nitrates is increasing the aphid pressure and stuff like that. Now, why is that? There's one golden rule. High nitrate is low brix. So there's the correlation with brix again. And we know what happens. So probably the reason that we have a brix of 7, but hopefully we have some people in the audience that are going to measure an hour after they watch the video.
So we're expecting feedback.
So we are expecting some feedback like, hey, my brix is this and my brix is this. And then also interesting, maybe we have somebody growing outside, for example. That would be really interesting because we don't have that data.
And Mark, a small question also. You mentioned high nitrates, low brix. Is it also vice versa? High brix, low nitrates?
Yeah.
Okay.
Because what nitrate actually does, it's when nitrate is in the plant sap, it's also EC, it's giving more EC. That is also pulling more water into your cells and also the plant sap. So actually you are diluting your complex sugars and your secondary metabolites.
So by using this, I know my brix, I can understand a little bit about calcium and also nitrates. Kind of,
yeah. Definitely if
with
you have
13 euros.
Yeah, if you go to China, it's really cheap, yeah. Now, I think I put one more here. I put the number of boron. For example, in the beginning of the crop, pHs are really high. You see that the uptake of boron is in trouble. But now, and we're also doing something with foliar application, so we really see that the boron is increasing. But it's still not helping us enough to get all the sugars out of the leaves.
It's a multidisciplinary perspective.
That's with everything. There's always one other factor that's influencing the total story.
The higher the better?
No, because with boron you can get boron toxicity. You get the scorches on the side of the leaf, so definitely the higher is not better. As guidelines, the laboratory use this tram lines, let's say. There is kind of a minimum and maximum.
But this is coming from a total average, right?
Yeah, it's kind of an average. So if you're in between the lines, you're kind of safe.
Yeah.
I am more and more experiencing that for some minerals we really need to be higher, especially the trace elements.
But now, for example, because you have the highest spike also compared to previous year, like at 12, you don't see any toxicity.
You don't see any issues. Okay. And also here, boron, immobile element, so the number in the old leaves is always higher than in the young leaves.
Of course.
Yeah. And especially the trace elements, they are really important. And also we discussed that last time in the pyramid, in the active immunity, because trace elements are more or less taking care of all the complex conversions with making oils, fats, secondary metabolites. That's where we need trace elements for. Yeah. We don't need nitrogen or calcium or boron. The trace elements are doing that.
Clear.
Right. Thank you.
I think that was the plant sap lecture.